So far we've gone through how to figure out yields, we've learned how to figure out limiting reagents. Now we're going to bring it all together and we're going to worry about all our reactants at once. So if we have the combustion of C2H6 with O2 to produce CO2 and water and inert gas and nitrogen, how would we figure out how many moles of products we finished with, how many moles of reactants were left, how many moles we had in the total system. So to save some time in this video, I've already written it up. The reaction here, 2 moles of C2H6 react with 7 moles of O2. They give you 4 moles of CO2 and 6 moles of H2O. In this case, we're going to start with a gram of C2H6, a gram of O2, and a gram of nitrogen. Now, we're going to calculate everything using what's called an ICE table. Now, the ICE stands for initial, change, and equilibrium. Now, we're not dealing with reversible reactions, but the idea is that E is going to represent what we have when we finish. So, to build your ICE table, you want 4 rows. You're going to have your initial, your change, and your equilibrium. Now, initial is going to represent whatever you began with. Change is going to be what you see as the reaction occurs, and equilibrium is going to be what you get when you finish. Now, when you build an ICE table, I recommend you highlight 3 regions. First region we're going to highlight here are the reactants. And I recommend you keep these in the first couple of columns. Reactants. In here, you're going to put C2H6 in one column and O2 in the second column. The reason why you want to group the reactants is the change is always going to be negative. You're always losing reagents when you run a reaction. You never gain them back. Second set of columns, I would recommend you make your products. Now, the reason I recommend you group the products together is that for the products, the change is always going to be positive for the reaction. You're always creating products when you run a reaction. Now, if you happen to have this in your problem, I'd recommend you keep these to the far edge. And these are what are called inerts. Now, inerts are compounds that don't participate in a reaction. So I said here we've got 1 gram of N2. Well, nitrogen is not shown anywhere in our reaction, so it's not going to run. We're going to finish with as much nitrogen as we started with. So our change here for the inerts is always going to be 0. Now, let's look at our nitrogen. We start with 1 gram of nitrogen is our inert. This converts to 0.0357 moles of N2. In terms of our products, CO2 and H2O, we don't start with either. In terms of C2H6 and O2, we start with a gram of each. And this is going to translate to 0.0333 moles of C2H6 and 0.313 moles of O2. Your ICE table always needs to be in units of moles. It's no use to have this in terms of grams. If you want to keep an extra row below and above because you're given grams or you want to finish in grams, it's fine. But the actual part where you'll be doing the initial change and the equilibrium all need to be in units of moles. Now, if you don't know how to figure out limiting reagent, go back and calculate it for this video unit being O2. If you also don't know how to calculate yields, go back and check those videos. The changes are going to correspond to whatever you would get based off the limiting reagent. Now, for limiting reagent, this is easy. We know the limiting reagent runs out, so the change in moles for the O2 is minus 0.313 moles, which will give us 0. So limiting reagent, that one's already filled in for you. You should always have 0 moles when you finish. If we take our moles of O2 and convert to the necessary moles of C2H6 to react with it, we get 0.0313 moles of C2H6. Now keep in mind, for the reactants, this change is always negative. And so when we finish, we're going to get 0.0020 moles of C2H6. Now for the products are kept in their own column because we're always increasing them. So whatever change in here is going to be positive. In the case of CO2, this is 0.0179 moles. In the case of H2O, this is 0.0268. Again, if you don't know how to do this, go back to the previous videos, look at how to calculate yields. This is all based on straight moles. Nice thing about the products, generally we're not starting with any. We're just going to add our starting products to our change. We get 0.0179 moles of CO2, 0.0268 moles of H2O. And again, the nitrogen, because it's an inert, is never going to change. And this is the power of the ice table. All it's meant to do is create an accounting. Again, it works great if you keep the reactants and products separate, so you always remember which way the signs change. And if you happen to have inerts or gases in there that just don't do anything, they're going to stick right here.